I'm Justin Davies,
I'm Jeff Talbot.
and we're at ECE 3130 Microcomputer Systems.
Raise your voice, please.
This is a fall 2019.
Okay.
Our project was a micro Pong kind of style game. It's two-player head-to-head, and the player inputs are controlled by two rotary encoders. So as you turn, the player paddles follow.
You want to play one?
Yeah, we can play one to
give an
demonstrate. Basically, both players have to push down on the knob to indicate that they're ready. So if we both push down, the serve will come out, and the ball bounces back and forth.
Like your classic game of Pong.
Where the ball strikes on the paddle will change the angle. If you hit in the middle, it'll...
Got him.
And it updates the score on the 7-segment display. If you want to talk about the rotary encoder stuff?
So basically we interfaced our Dragon board with two rotary encoders and an 8x8 LED matrix. As you can see, the rotary encoders are inputted to port H here, and we outputted ports M and A into the LED matrix for the display. Basically, the rotary encoders, they have two data wires and a switch wire, and they'll take those data wires, and it's constantly pulling through the RTI and compare it to the clock. It's comparing the stages, right?
Yep.
So if a state is changed, if a state changes, it'll compare the clock signal to the data signal, and if they're the same, it'll shift left. If you turn it counterclockwise, and if they're different, it'll shift to the right, turn it clockwise, and it's opposite for this one.
Right, because they should be. It's kind of a head-to-head game.
Right, so it's back and forth.
You can talk about the display multiplexing if you want.
Yeah, so we have, when you play the game, you see the ball bounce. There's 3 objects. You got the 2 paddles and the ball. They're time multiplexed. So each object's displaying for about 1 millisecond each. Each one's going through an RTI separately. So it's also, each object's on an XY plane. The X positions, they have to be complemented. Complemented and ran through port M and port out, because these LEDs, the X positions are connected to the cathode part of it. So that's to ensure force biasing, so we can turn the LEDs we want on, and through reverse biasing, we keep the ones we want off. And then the Y coordinate of them are they're written through port A, and they don't have to be complemented everything, because they're just connected to the anode part of the LEDs. We got 1,000 ohm resistors in there just to dim it. We started playing around with it with our family and friends, and they said that the LEDs got too bright, so we tried to. So we threw in. We actually had 330 ohms.
Yeah, we started with small resistors, but it's too bright. It was kind of hurt your eyes.
Maybe I have a question here before you continue.
For sure.
So here, these LEDs.
Yes.
They get power from the board, right? So the board gives them enough power so that we can get good lighting here, right?
Correct.
Good light. Okay. Because sometimes if you don't if you cannot get enough power from the board, you have to connect something like what we call buffer or drivers or something.
Sure.
But
Yeah,
here you don't need, right? You connect them directly to the board, right?
Yes. The specs for these LEDs are pretty low voltage.
Maybe
so
that's
actually,
why.
Yeah, they're like 3 volts roughly, and so this board outputs like 5 volts. So we had to bring it down. I actually damaged one of them because I overvoltage those. Mistake. But yeah, so
I can see the light is acceptable here. The level of the lighting is acceptable.
Right.
So yeah, like you said, the LED 8x8 matrix is time multiplexed, as is the 7-segment display, so you can show the player scores. Those are also time multiplexed, the same idea.
Okay, what do you use here for time multiplexing of the 7-segment?
RTI.
RTI.
Yeah, so in RTI, it just toggles back and forth whether it's showing player 1 score or player 2 score.
Yes.
And then also in RTI, it cycles through, game object 1, which is the player 1 paddle, and the ball, and the player 2 paddle. So
Okay, and these the switches are connected to PH ports, right?
Yep.
PH.
Port H, so the player 2 is
So you
connected
don't use any other interrupters, only RTI, right?
we use RTI. We also use the timer counter, and that's for the frequency of the tones that we emit.
Oh,
so
we do
if
that
you
for-
listen, if you listen, the tones are different. So we'll just like a
okay.
so-
So you use what do you use here? Output compare, or what do you mean
yeah,
by?
output compare.
Oh,
and
great.
then-
So you
and
use
then-
also output compare for the sound.
correct, and we basically queue up different sound frequencies.
Oh, you also
So-
change the frequencies?
And so,
How?
did you hear?
I didn't capture this.
Bum, bum, bum.
But the same frequency or different?
No, different note.
Different note?
Yeah,
Oh, now it's a different note. Okay.
you hear that?
Okay,
It's
great.
a little
That's
faster.
really
so,
good.
So that's changing the frequency, and I try to make them like musical notes, so they sound kind of nice. It's not just like 500 hertz.
Yeah.
It's actual musical notes.
And now you already, someone already won.
Yeah,
right?
the score limit is 3, just to keep the games kind of.
Oh, yeah, that's okay. Just,
and then
we can
once you
change
hit it again, it restarts, so the game constantly
yeah,
runs.
yeah. But really, you know what really I like about it? It's not. It's really. It's very interesting. You do something really, but it's not too complicated. By the way,
No.
programming wise, use one RTI, use output compare. It's not. It's not too complicated, but it's a very interesting project. Anything else you want to add?
The collision is kind of neat. If you want to talk about how we bounce the ball, basically RTI counts, and then there's a ball speed variable that decreases every time RTI runs through. That's why it gets faster and faster. So like the time it takes. And what we do is we just shift the byte where the ball is stored. So it's like we shift back and forth. And then when it gets into this top row, it'll reflect it down, and if it's in the bottom row, we reflect it up, and then depending on where it strikes in the paddle, it can either go straight or bounce up and down. So if you look, if I hit strike in the middle, it'll go up and down, or sorry, it'll go back and forth. And if I hit on one of the corners, it's randomized. Sometimes it will bounce up or down depending on its side.
How you made it random this way?
So I just used an overflowing counter, just something that gets incremented every time. I probably could have just used like one of the other timers and just pulled like the least significant bit, and so that way it's constantly going back and forth 1 and 0. So it's like it's not truly random, but you can't really predict. You know.
Okay, you can predict. But maybe one more question about programming the LED metrics.
Yes.
It was difficult to program it, or how you programmed it?
Okay, so it's got 2 bytes. 1 byte controls all of the x-axis connections, and 1 byte controls all the y-axis connections. If you notice, it's 8 by 8, right? So
Okay.
1 bit per location.
Okay.
And so then what we did, what Justin was explaining was the x byte is connected to the cathode part, so it's got to get complemented. So it basically puts a negative on one side, and then we write the y part, the y byte as is, so that it puts 5 volts high on the correct part of the correct LED, and then it gets the low on the opposite side, and then we reverse bias every other LED that we don't want to turn on.
Okay.
So it just cycles through.
Okay. Thanks, guys. I really appreciate it.
Thank you. That's fun.
Fun.